Hey guys, how is it going? So, just a quick video here about lipids. Now, we're going to talk about how they're made mostly. There's three main classes: glycerolipids, they all have a glycerol backbone; phospholipids, they all have a phosphate and a head group in there somewhere; and sphingolipids, they have a ceramide backbone. Now, there are different subtypes within there. Triacylglycerols we've already talked about. I'm not going to talk about those. Glycerophospholipids, they're made from phosphatidic acid and a phosphate in a head group, and those are glycerolipids and phospholipids. We've got ether glycerolipids. Those have made from DHAP, two fatty acyl CoAs. They can be the same, they can be different, doesn't matter. Only one of them is really going to stay the whole time. Plus a fatty alcohol and a phosphate with a head group. And then sphingolipids are sphingolipids that are also phospholipids. They have a ceramide backbone and then a phosphate with a head group, and then finally glycolipids, a ceramide backbone and a carbohydrate, because what's in carbohydrates? Sugar. Okay. Okay, so let's go ahead and start off looking first at glycerophospholipids. Now there are kind of two ways that depending on what order these steps are done in, going to determine what kind of glycerophospholipid you get. So let's take a look down here going on the left. First, you got your phosphatidic acid. If you get rid of the phosphate first, giving you a diacylglycerol, concurrently you'll have your phosphorylated head group that will use cytosine triphosphate to give you a CDP head group. Then those will react to form your glycerophospholipid. Examples are phosphatidylcholine, phosphatidylethanolamine, or phosphatidylserine. Whereas on the other way, if you have the CTP added before you kick off the phosphate, or while you kick off the phosphate, you have a CDP diacylglycerol, and therefore you have a head group that doesn't have phosphate attached to it already. So it'll just come in, combine with your CDP diacylglycerol, and give you a glycerophospholipid, such as cardiolipin, phosphatidylglycerol, or phosphatidyllinositol, which I'm not saying right, probably. Ether glycerolipids. Okay, now this is kind of hard to describe because without being able to draw out structures, which in these maps is not easy. So just kind of bear with me here. Ether glycerolipids, as you can probably imagine, are named as such because they have an ether. So first off, you're going to combine your DHAP, which is going to be your backbone, with a fatty acyl CoA with an R group. The CoAsh is going to leave, and then you're going to be left with this structure here, where you've got your three carbons. The first one has an ester to the fatty acid on it. Your middle carbon is just going to be your ketone, just like in DHAP, and then also like DHAP, you've got carbon 3 that has the phosphate on. Meanwhile, you've got a fatty acyl CoA with a different fatty acid on it, so it's going to be R1 instead of R. That's going to get reduced, so instead of a ketone connecting them, ketone at the carbon that connects them, you've got an alcohol. So instead of a fatty acid, it's a fatty alcohol. So those are going to react. It's going to kick off the ester group, and it's going to, with your R, and then your R1 is going to stay, and it's going to form an ether because we were able to set that up by reducing the ketone to an alcohol. So we've got an ether on carbon 1. We still got a ketone on carbon 2. And we still have a phosphate on carbon 3. The next step, you're going to reduce the ketone, so it's going to, and then we're going to add fatty acid or fatty acyl CoA, the chain R2, that's going to be added on. We're going to dephosphorylate or kick off the phosphate at carbon 3. So carbon 1, we've still got the ether that links to R1. Carbon 2, now we've got the ester linking to R2, and then carbon 3, since we got rid of the phosphate, we just have a regular alcohol. Now we're going to add in, this is our phosphate with our head group on it, our cytosine diphosphate, ethanolamine. And so that's going to, of course, add on to carbon 3. And so it's going to give us still the ether on carbon 1, the ester on carbon 2, and now the phosphate with ethanolamine on carbon 3. And so what we're going to do now is we're going to reduce basically the chain with the ester on it. We're going to turn that alkyl group or bond into a double bond. So it goes from an alkane to an alkene, and everything else is going to be the same. So we've got the ether there, and that specific one is ethanolamine plasmogen, which plasmogen, I guess, is a class of ether glycerolipids. And then finally with sphingolipids, there are two types, and they're to start off, they're pretty much made the same way. You're going to have your palmitoyl-CoA, which, if you remember, is, I believe it was 16 or 18 carbons along fatty acid, and then that's going to have serine added to it. So you've got this little, and get rid of a carbon, get rid of a coash, and that's going to give us, it's basically going to be a serine and a palmitate, where if you know serine's the amino acid, it's going to be hooked on through the carboxylic acid end. So we'll still have the side chain, which I believe in serine's case is just another carboxylic acid, and then it's also going to have the amino group. So that alcohol is going to be reduced, or the ketone that connects them is going to be reduced to an alcohol, the ketone from the palmitoyl-CoA part, and so we'll just call that reduced serine palmitate. I don't know if these intermediate structures have names. I just named them according to how I thought would be a good way to describe them. And then we're going to add a fatty acyl group to the amino part of, or the amino group in the serine part of the substrate. So if you just, picture an amino acid, you've got an amino group on one end, a carboxylic acid group on the other end, and then the side chain. The amino group, we're just going to kick off a hydrogen and attach our fatty acids straight onto that. So now we've got a reduced serine fatty acyl palmitate structure. So we're going to use FAD. We're going to oxidize our substrate. Going to desaturate the palmitate. So we're going to be able to get a double bond into there at the carbon adjacent to the OH containing carbon. And that's, remember, is the carbon that's going to be attached to your side chain, because that's what's got, or no, the ketone from the, your palmitate. And what that is going to do is that's going to give you ceramide. And then I put a note here. From here, so we're going to be adding some things on. The groups will be added on to the first carbon with the alcohol attached. The one that was originally the side chain of the serine when we began. So it'll be on the serine portion of the molecule, or the one that started off as serine. And we're going to be adding on to where the side chain was. It's the only carbon that doesn't have a significant group on it. All the other carbons have either like a fatty acyl group on it or something at this point, except this one. So that's what we're going to add on to. If you want to add phosphatidylcholine, it'll get rid of a DAG and it'll give you sphingomyelin. Add UDP glucose, it'll give you a glucocerebroside, which I guess can react further to become a globoside. The glucocerebroside, if you add UDP sugars, is CMP-NANA, which is an acid, like N-acetyl something acid, I don't remember the name. That'll give you a ganglioside. Or if you want to do just throw UDP galactose onto the ceramide. And keep in mind, these, where we're throwing sugars on, those are obviously glycolipids, because we're putting carbohydrates or sugars on there. That'll give you a galactosebroside, and it can, an enzyme called PAPS can turn that into a sulfatide. I don't really know. Okay, so that's how we make lipids. Hope it was helpful.